All right, everybody, welcome. It is Thursday, and I'm starting on the 2015 FRQs, problem number 1. Looking at part C, asking at what time in between 0 and 8 is the amount of water in the pipe a minimum. They give you the rate that the water is entering and the rate that the water is draining. So we're going to set R of t equal to D of t because setting the rates equal to each other gives us when the water level is either going to be a max or a min. We have a closed interval from t equals 0 to t equals 8. When we set R of t equal to D of t, we get t equals 3.272, okay? So the water is going to be at a minimum at either when t is equal to 0, t is equal to 8, or t is equal to that critical number, which is 3.272. We're given that there are 30 cubic feet of water. There's 30 cubic feet of water in the tank at t equals 0. Now we have to figure out how much water there is at t equals 3.272 and how much there is at t equals 8. Well, at t equals any value other than 0, we're going to have that the amount of water in the tank is going to be that initial amount plus the integral from 0 to 3.272 of R of t dt minus, because that's how much water entered the tank. If R of t is the rate that water is entering the tank, that's how much water entered the tank, minus how much water exited the tank or drained from the tank. So that'd be the integral from 0 to 3.272. And really, I'm saying 3.272. You should keep that as far out as you can. So that's 1/6 dot 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 1/6 dot dot dot, right? And this would be of d of t dt. Okay. And then for t of 8, again, it would be 30 plus, this would now be the integral from 0 to 8 of R of t dt minus the integral from 0 to 8 of d of t dt. Okay, so again, 30 is there because that's the initial water in the tank. This is how much water entered the tank because R of t is the rate at which water is entering the tank. So the integral from A to B of that is how much water entered the tank on that time interval. And this is how much water drained from the tank on the time interval from 0 to 3 point whatever. Okay, so you find that value and then you find that value. So we already know that there was initially 30 cubic feet of water. Once we figure this out and this out, which I'm just going to go to the scoring guidelines to get those values. 27.965. $27.965 is going to be, when t is equal to 3.272. And then at t equals 8, it has that there's 50. So this is the going to be the least amount of water in the tank, and that occurs when t is equal to 3.272. Okay, so that's how you should answer the question. Let's see what they say. The amount of water in the pipe at time t in between 0 and 8 is going to be given that. Again, this is initial amount of water plus how much water entered minus how much water drained, right? And so setting R of t equal to D of t or R of t minus D of t equal to 0, we get the 3.271658. We get these values. So the answer is the amount of water in the pipe is a minimum at time t equals 3.272 hours. Okay, so that's 1C. Okay, what else would you like to see from the 2015 FRQs 1, 3, 4, and 5? Arian asks for 4D. Let's check that out. Okay, so we have 4 is this differential equation. We were asked to do the slope field. Someone's at my front door. I think that's our neighbors. Okay, here we go. Hold on one second, guys. Hold on one second. Hey, Olivia's doing a Google Meet session with her teacher right now. Okay? Hello. They want to say hi to Olivia. Okay, so given this differential equation, what did it ask for D? Let's see. Oh, for B is one that you guys want first, and then we'll do 4D. So given this differential equation, it says axes provided. I hope the slope field is pretty easy for you guys. We're just plugging in when x is equal to 0 and y is equal to 2. So when x is equal to 0 and y is equal to 2, we get -2 for that. And so the slope is -2. And so we would do a little line segment that would look like that. And then you do that for all of those. Anyway, so that's A. B says, find the second derivative in terms of x and y. Determine the concavity of all solution curves for the given differential equation in quadratic, in quadrant 2, meaning when the x and y values are both negative. Give a reason. Okay, so first let's find the second derivative. So we are going to differentiate with respect to x on both sides of the equation. So when we do that, we're left with the second derivative of y with respect to x is equal to, so the derivative of 2x with respect to x is just 2 minus, and then the derivative of y with respect to x is 1 dy dx, or just dy dx. But dy dx was given to us as 2x minus y, so this is equal to 2 minus quantity 2x minus y, also known as the second derivative of y with respect to x is 2 minus 2x plus y, okay? So I've now found the second derivative in terms of x and y. And now they ask me to determine the concavity of all solution curves for the given differential equation in quadrant 2. So in quadrant 2, I have a negative x value and a positive y value, right? Quadrant 2, I have negative x and a positive y. So in quadrant 2, x is less than 0 and y is greater than 0. So when I plug in all values or any points where the x value is negative and the y value is positive, I'm going to have 2, and then that's going to be positive because when you, -2 times the negative value is going to be positive. And y is always positive, so everything is going to be positive. So the second derivative of y with respect to x is always going to be greater than 0 there, which means that, so the solution curves will all be concave up because of this reason right there, because this is the second derivative of y with respect to x, and x is negative and y is positive. Did that make sense for you? Cool. All right. So then there was C, which asked us to, I need a better way of managing this guy. Okay. So C asks us to give us an initial condition, and they're asking if F has a relative min, max, or neither at x equals 2. So at x equals 2, y is equal to 3. So what you would do there is plugging that 2 comma 3 into the original. So 2 comma 3 into the original. Sorry, into the derivative. I get that the derivative has a slope of 1. If the derivative has a slope of 1, then there should be neither a relative max or relative min there, right? Let's check out square root. So for B, they had the second derivative. In quadrant 2, x is negative, y is positive, so that's always going to be positive. So all solution curves are concave up. Part C, we get that the derivative at that point is not 0 because it's 1, so it's not 0. So there's neither relative min nor relative max there. Easy enough, right? Okay, and then we get to D. D says find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. Sorry, let me go back to this. Is a solution to the differential equation. Okay, so remember the differential equation was equal to 2x minus y. So the solution, y equals mx plus b. All right. Really quickly to expedite this and just look really quickly. Yeah. Okay. So the fastest way to approach this. So if we did have a if we knew that this was the initial function, right? So that's the solution to the differential equation, meaning that that is the initial function. And we were to approach it by differentiating this with respect to x. We're going to find that dy dx is just equal to the derivative of this thing, which is just m. Okay. So, okay, let me pause really quickly before I go any further. Just looking at this differential equation, we cannot solve this differential equation by using separable differential equations. Do y'all see that? You could say, oh, just subtract y. No, because if you subtract y, you still got to get the dx over here. And if you multiply both sides by dx, it's going to be y dx. So that you're not going to get rid of it. So this is not a separable differential equation where we can solve by using, separable differential equations, by using the separation of variables and all that. So we have to approach this by, oh, they're giving us that the solution is this linear or y equals mx plus b form, which means that the derivative is just the slope, right? If we have a line here, then the derivative is just the slope. So now we're going to set dy dx equal to dy dx. So 2x minus y equals m, right? Let's check this out. Yeah, so setting that equal to the slope. Oh, they turn y at that point, right? If we were given, wait a second, y was mx plus b. So instead of, because right now you have m is just some constant that we're solving for, but we have two variables, x and y, but y is mx plus b. So this is 2x minus mx plus b equals m. Then we have, 2x minus mx minus b equals m. Solving for x, we could factor out an x over here, and this becomes 2 minus m equals, adding b to both sides, we have m plus b. So we get x equals m plus b over 2 minus m. What do they have here? So they have this, which is what I have. I brought the m plus b over to this side. They're just saying this has to be equal to 0, because what are we looking for? Is a solution. Do you guys see, why are they setting this equal to 0 right here? 2 minus m equals 0.
I think they're just like setting the two, guessing or finding the two values that would set those both to be 0, so that the whole thing is 0, or
Let's see what I have really quickly. Let me look at this. Let me, I don't want to take up too much time. Let me look at this, of why they're setting 2 minus m equal to 0, because it's not popping out at me right now. Yeah, I'll look at, what is that? 4D. And I'll get back to you on that. 4D. Y set 2 minus m equal to 0. Anyway, I'll get back to you on that one. Yeah, that's, it's not popping out at me why you would do that. If you're solving for m and b, I think what they're saying is if you're solving for m and b, x is a variable there, so you need that to be 0, that term to be 0. And so if the 2 minus m was 0, that's going to be when, yeah, that's going to get rid of this, so we can only talk about m and b in terms of the constants. But yeah, I'm not, like I said, let me look at that, then I'll have that ready for you. In fact, I'll at least upload that for tomorrow, by tomorrow, so we can talk about that. All right, so that was, let's see, and 5A and D is what 3D. Let's go back to 3D. Okay, so we have Johanna jogs along a straight path between 0 and 40, and her velocity is given by differentiable function v, which is right here. Selected values of v of t, where t's measure is given, measured in meters per minute. So t's in minutes, and v of t is meters per minute. And then they talk about Bob right here. Bob is riding his bike along the same path in between 0 and 10 minutes, and Bob's velocity is modeled by this guy. Find Bob's acceleration. Based on the model B from part C, find Bob's average velocity during the interval from 0 to 10. Okay, so we're not even using this table because it's only based on Bob, and they give us the rate at which he is riding. So, average velocity. Listen to this, people. This is an important distinction. So listen, for average velocity. If we were going on a trip, let's say, the example that I think I gave in class this year was we're going to Vegas and I rented a bus and I'm driving the bus and we're driving, and let's say that it's exactly 200 miles to get to Las Vegas, and we end up getting there in exactly 4 hours, okay? So it's 200 miles, and we get there in exactly 4 hours, okay? Well, if I ask for the average velocity or the average rate at which we're traveling, right, or average speed, what that would be is the total distance divided by the total time, and that gives us an average velocity. So that'd be 200 miles per 4 hours, also known as 50 miles per hour. Okay, so that's a distance. So if you're given the distance function or something like that, and you were asked to find the average velocity, that's like your f of b minus f of a over b minus a. That is an average rate of change based on what you're given. Okay? That is not what we have here. Because here, they give us the velocity function. They're asking for the average of this function. So this function's average, because this function is the velocity. So the average velocity for this problem is like a FAV type of problem, where the average velocity, average value of the velocity. So what this is going to be is velocity average is equal to 1 over b minus a times the integral from a to b of that thing, and that's going to be with respect to t. So let's go back through and say, okay, from 0 to 10. So that's going to be 10 minus 0. And this is going to be from 0 to 10. And this right there is just going to be b of t. Like that. This is the average velocity because b of t is the velocity function. So let's see what they have here. Yeah, average velocity is 1 over b minus a times the integral from a to b of b of t dt, which they end up getting 350 meters per minute, okay, when they work that out. Did that make sense? Lizzie, I think you asked for that one. Did that one make sense to you? It's that distinction between if they gave us a position function or distance or something like that, then we would use f of b minus f of a over b minus a. But because they give us the velocity and they ask for average velocity, it's the average value of that function, which is like the FAV type of question that we did. So that's how that one can be a little bit confusing. Anyway, so that was that. And then you guys asked for 5A and 5D. So let's look at 5. So this is 5. So here we go. It says, consider the function f of x equals 1 over x squared minus kx, where k is a non-zero constant. The derivative of f is given by that guy, which you could find by just doing, if we treated this as like f of x equals quantity x squared minus kx to the negative first, and then you could either, starting from here, do the quotient rule, or you could do the power rule with the chain rule, how I have it right there, but you're going to get this. Anyway, they give that to you. So then they say for a, they say, let k equal 3. So we have f of x is equal to 1 over x squared minus 3x. Write an equation for the line tangent to the graph of f at the point whose x-coordinate is 4. Okay. So now x is equal to 4. So we have, if x equals 4, I know that an equation of a line with an x-coordinate of 4 is going to look like this. Y minus f of 4 equals m times quantity x minus 4, right? So y minus y1 equals m times quantity x minus x1. That's what it's going to look like. Well, they give us that x is equal to 4. To find the y value, I could plug 4 in for x in for this. So f of 4 is just equal to 1 over 16 minus 12, which is 1/4. Do you guys see that? So that's what this, instead of f of 4, I'm going to plug in 1/4 in for that. So far, it looks like this. And now there's only one thing left to do, and that is to find m, which is also known as f prime of 4. Well, they tell us no matter what k is, this is f prime of x. So for this guy, f prime of x equals, well, when k is equal to 3, so that's 3 minus 2x over x squared minus 3x quantity squared. So what is that when x is equal to 4? Well, that's going to be your m. So f prime of 4 is 3 minus 8, so negative 5 over, and let's see, when x is 4, we have 16 minus 3 times 4 is 12, quantity squared. So that ends up being 4 squared is 16. So this is negative 5 over 16 is what I get. Negative 5 over 16. So that's what I have for the equation of the line tangent to the graph of f at the point whose x-coordinate is 4. Let's see what they have for 5a. So they moved over the 1/4 there, but they have y equals negative 5 over 16 times quantity x minus 4 plus 1/4. I think that's the same thing I have, right? Negative 5 over 16. Yeah. So that's what they had. But they did not ask for any particular form of the line. So what we have, I would just keep it like that in point slope form. Okay. Okay. So that was 5A. And then you asked for 5D. Okay. So 5D says, let k equal 6. So now we have this guy. Find the partial fraction decomposition for the function f. And then find the integral of f of x dx. Okay, so this is integrating by partial fractions. So really we start with 1 over, this ends up being, well, just x times quantity x minus 6, right? the denominator is. So this is 1 over x times x minus 6 equals a over x plus b over x minus 6. So this is partial fraction decomposition, which is what they asked for. So here, by multiplying both sides by x times x minus 6, I'm left with 1 equals a times x minus 6 plus b times x, right? So now what we say is when x equals 0, I get that 1 equals negative 6a, so a equals negative 1/6. When x equals 6, I get 1 equals, now when x is 6, the a term is going to go away, right? So I'm just left with 6b. So b equals positive 1/6. So therefore, this fraction right there, the 1 over x squared minus 6x, can be written as, so 1 over x squared minus 6x is really equal to negative 1/6 over x plus 1/6 over x minus 6 is what we just found out because I solved for a and b. So the way I would say that is this is just equal to, maybe I'd factor out a 1/6, and I'd have like 1 over x minus 6 minus 1 over x. I'd maybe treat it like that, okay? So this was finding the partial fraction decomposition. Did that make sense? Do you guys remember doing that? Maybe.
I remember doing that.
Cool. Okay, so now what we're doing is we are finding the integral of the function. So the integral of this thing, so I'd factor out my 1/6, and I'd have 1 over x minus 6 minus 1 over x dx is equal to 1/6 times, that becomes ln of absolute value x minus 6 minus ln of absolute value of x. I'll put my plus c there. And you could leave it like that. They might have it, and I'm curious to see if they would leave it like that or have it as this. They might have it like that. Let's see how they have it. Well, they have both there, right? They have this. Now, they didn't factor out the 1/6, but they have this, and then they have, which equals 1/6 times ln of absolute value x minus 6 over x plus c. So for this problem, they gave 2 points for the partial fraction decomposition and 2 points for the general anti-group. Kayla asks, what if we don't simplify? Yeah, you don't have to simplify. For the free response questions, which is all that you are going to be given for this year's AP exam, they don't, as long as what you have is mathematically correct, they don't require you to simplify. So if you have this, or like, because you can see they have this without the 1/6 being pulled out. Or they have this, or if they had what I had where I factored out the 1/6 of that, all those are correct, and therefore you get full credit if you have any one of those. So don't worry about simplifying for the AP exam. In fact, they encourage you not to simplify. Okay, anything else from 2015? So I'm waiting for you. Anything else from the 2015 AP exam? Okay. Which means we're on to 2014. Okay, 2014. Here's what we got going on. 2014, problem number 1. Grass clippings are placed in a bin where they decompose. For a time in between 0 and 30, the amount of grass clippings is given by that, okay? Find the average rate of change of A. That's A av, right? Find the value A prime of 15 and interpret the meaning of that. Anyway, so you have 2014 problem number 1. We're skipping problem number 2. I think we already did that anyway, but that is polar, and that will not be on this year's AP exam. Problem number 3, given a graph, this one happens to be the graph of F, and then they ask you questions about G, and they tell you that G is the integral from -3 to x of f of t dt. The big thing that you have to realize there is what that then means is that G prime of x is equal to f of x. That's a hint I'm giving you right now. Anyway, so that's number 3. So you're doing 1 and you're doing 3. And then what else do we have there? Oh, I'm surprised. There's a table of values, right? They give us problems where they give us just functions, or they give us graphs, or they give us tables of values, right? And they ask a bunch of stuff based on that. So that most definitely is a very common theme. It is a common theme with these, the calculus free response questions. Anyway, and then here we have shaded region, so you are looking at number 5 as well. So just like for 2015, the 2014 questions that we're looking at are 1, 3, 4, and 5. 1, 3, 4, and 5. That's what we're working on. Now, what I'm going to say is, tomorrow's Friday. I typically collect, homework and stuff on Friday. I'm going to go 2 weeks this time, meaning that tomorrow I don't need the work. Wait, did I already put that in or not? Under the classroom. No, I haven't. Okay. I'm not putting that in yet. I'm going to have the next batch be kind of like a double batch. So by next Friday, I'm going to have it where all this work is due, okay? But I don't need you to turn anything in tomorrow. Just start working on the, so to do, to work on. 2014 FRQs, problems 1, 3, 4, and 5. Okay? And then, in addition to that, whatever you have questions on, whatever major concepts that you have questions on that you want to see me reteach, maybe that's what I'll focus tomorrow's session on. Tomorrow, I have my math department meeting from 8:30 to 9, and I have my staff meeting. I want to say that's at noon. So let's say at 9 a.m. tomorrow, if you want me to reteach, or if you're feeling like, what I put on here for the curriculum, the AB and BC curriculum, and then, all the questions that are done, worked out for you, the FRQs that are worked out for you on YouTube. I'm hoping that those are good resources, along with obviously Khan Academy. is a huge resource, which I already put you in the class for that. Let's just have tomorrow. If you want to hop on tomorrow at 9 a.m., which last week, like, no one showed up, which I'm okay with that. If you are working on your problems and you don't need anything, that's totally cool. But I'm just going to leave tomorrow at 9 a.m. open for, if you have any questions where you might want me to like reteach something and you can't find it like on these resources that I've provided, or you just have a general question, whatever, I'll leave tomorrow at 9 a.m. For that. Okay. All right. You guys all eating a lot of carrots still? You eating healthy? You going outside, getting some exercise? Is anybody still there? Oh, someone's there. All right. Cool. I miss you guys, man. I miss the little interactions, daily interactions of seeing you guys and just hearing all your dumb comments. Not mentioning anybody in particular, but the silly little comments and everything else. I miss that stuff. So I hope you guys are doing well. And like I said, if you want to hop on tomorrow at 9 a.m., we'll just answer whatever questions you have. They could be general questions, they could be reteaching, whatever. And I'll record that if anybody shows up. And if no one shows up, then I won't. Arian, you did not dye part of your hair blue. Come on. You got to show us.
I did.
Come on, dude. Let's see.
Wait.
Show us.
Can you see it?
No.
I turned on my video.
Oh, I do. I see it. I see it right there.
Yeah.
Boy, both my daughters have pink in their ponytail, which we've never allowed them to have before, but pretty fun.
Yeah.
Should I do that? Should I do a little something? I don't know.
Yeah.
I want to mess up my silver.
Roller, is that blue for UCSB?
What's
yes,
that?
Sir.
Roller, dye your hair pink.
Pink?
Yeah.
I think we ran out of the pink hairspray, and it's kind of tough to come by. Here, hair dye is, flying off the shelves these days. So I did, but it's not anything new, but I gave myself and my son a haircut. So, but yeah, I don't think I'm really going to be dyeing anything, any color. I think we'll just stick with the grayish silver that I got going on. Rock and roll, guys. If you want to join tomorrow, 9 a.m. Otherwise, have a great day, great weekend, and enjoy the beautiful weather outside. Get up early, take advantage of when it's not too hot, and do your work. Get it going.
Bye, girl. Have a good one.
All right. You too. Bye, guys.
Roller.
Bye.
See ya.